We are projecting the ball from the tower. So how the velocity vector will be directed? The velocity vector will be directed with the speed u at an angle theta with horizontal. Now the conditions are different. So we are throwing down. We are projecting vertically down. So how do the ball will move now? So we are throwing it. So how the weight mg will act, and the ball is given velocity like this. So it is going to move in a parabolic path and it will strike the ground here. It will be again a projectile motion. Agreed? So the first, what are the things? The weight mg will act. Let me show this. So how the ball is going to move in a parabolic path. Not a straight line. It should be parabola. So it will come and strike the ground with a speed v. Few questions like sir, with what speed it will strike? Then after what time it will strike? Again, the concepts will be same. We are going to apply the equations of motion along x, along y. So how the gravity will act downward. So after some time, the ball will have velocity v1. After again some time, will have velocity v2. And its horizontal component will remain same. Vertical component will keep on increase. We'll resolve this. U cos theta, u sin theta. Again, when striking the ground, u cos theta and v1. What will be the horizontal component? The horizontal component has to remain same. Why horizontal component should be remain same? Because ax equal to 0. There is no acceleration for the projectile along y-axis. Then who will provide acceleration along y-axis? The gravity. So first we'll calculate the time of flight. Then, so what is the initial point? This will be the initial point. And this will be considered as final. So, and the projectile now, this is the initial, when it moves from here to here in a parabolic path. What is the displacement? The vertical displacement will be h only. And how the vertical displacement will be downward. And how do this vertical displacement is in the direction of initial velocity. And how the gravity is in the direction of initial velocity. So when you are applying equations of motion, it will be plus h equal to u sin theta t plus gt square by 2. Why sir here plus h? Because when it moves from initial to final point, or the displacement is measured in the direction of initial velocity. So therefore h is positive. Why g is positive? Because the gravity will act in the direction of initial velocity. That's why the gravity is positive. Let's up to the values. So we have to solve this equation. So applying equations of motion is everything. See, like why the projectile motion? Applying equations of motion along x, along nothing more than that. So this will be plus h. H will be 40, 10, 1 by 2, t, 10, t square by 2, 40, it plus it square. Quadratic equation. Minus 5 plus or minus 25 plus 4, 5 minus 40. B square minus 4ac by 2 into 5. 25 minus, so this will be 4 5 ja, again 20 20 800 825 by 10. Like previously we had no root of 825 28.72, so minus 5 plus 28.7 by 10. The 28.7, we should take the positive root here. 23.7 divided by, so 2.37 seconds. So after what time it will come and strike the ground? 2.37 seconds. This is a time of flight. See, once again, I don't want to really trouble students. What is the projectile motion? Motion in one dimension along x, along y. 4. There's no need to make a big blast like projectile motion, this, that, even inclined projectile motion, anything. The entire kinematics is what all about. The use of equations of motion. Next, we'll go for the range. Range R is equal to, let me calculate here. The range R is equal to ux t plus ax t square by 2. What is the value of ux? Ux is u cos theta. Time of flight we know, and ax is 0. I 0. There's no horizontal, there's no any force acting on this ball along x-axis. So what all force acting in what direction the force will act? The force will act only along y-axis. And what is that force acting? Mg. Agree this. That's why we don't get any, there's no force. The what all the force is acting only along the y-axis here. There's no force acting along x-axis. I'll write it. That's why we're having this acceleration. How do we calculate acceleration? These are some small ideas, very useful for you. Let's calculate the range one. R is equal to U 10 root 3 by 2, 2.37. Let me calculate 1.73, 20.52. Okay, this will be the range. What about the speed? We'll calculate. So all the things what we calculated, I'll rounding off that one. So what do you mean by range? The horizontal distance from the foot of tower at which the ball will strike the ground. That is the range. Then we'll calculate the speed, this particular thing, with what speed the ball will come and strike the ground. So this particular thing, the Vx is given by u cos theta 10 root 3 by 2 pi root 3. What about Vy? Vy we don't know, that will use the formula. Minus Vy whole square uy square 2 minus g plus h. Now you have to be careful. Why negative sign for Vy? How is Vy? Vy is measured opposite to. So this should be positive. G is also positive. All the quantities will be positive. No. Why Vy is positive? Vy, how it is acting? It is acting in the direction of initial velocity u sine theta. Both are in same direction. Check it. Both are vertically down. So therefore, these are positive. Then what about G? G is also will act in the direction of u sine theta. So therefore, it should also be taken to be positive. What about h? H is a displacement. When it moves from here to here, what is the displacement? The displacement is downward, no? And how the displacement will act? Again, it will act in the direction of the displacement, also will act in the direction of initial velocity. So how is h measured? H is measured from here. So here we'll write it. This is h equal to 0. And we'll measure h like this. And how it is measured in the direction of u sine theta. So therefore, this will be positive. Substituting all the values, we'll get the required one. Vy square. Uy square will be u sine theta ten 25 root 825. So what is the total speed? The total speed will be given by next question comes like a look at the answer. Like if you project it will going to strike with the same speed. Whether you project vertically up or down. Okay, sir. Like a well, sir, how it is possible? Well, look at this one. How it is projected? It is projected half the incline. No? I need to strike with the speed. And what is the speed we got? 925. Projectile projected up the incline. Look at this answer. We are projected with a speed u at an angle theta such that the velocity vector was making angle theta above the horizontal and it was striking the ground with 925. What about in this case? In this case, we have projected here speed u with angle theta below the horizontal. Again, it will strike the same speed. So what is the conclusion we can make it here? If you project a projectile let me adjust. Small diagram. No? To diagram I'll explain. Easy for you. Now I'll project a ball with a speed u. It will move in a parabolic path and will strike the ground. With what speed? With a speed. Both are same identical towers. Here I'll project the ball with the same velocity or same speed. Look at that theta, it was above the horizontal, here below the horizontal. Now it is going to describe a parabolic path. And strike the ground. In both the cases, the speed has to be same. What about the time of flight? Will be different. Here it's a T1, T2. What about the range? Will be different. T1 not equal to T2. R1 not equal to R2. But V1 equal to V2 equal to V. This is something very, very important, which will go